Good morning, dear student. I am Mohammad Aman, Assistant Professor in United College of Engineering and Research, Allahabad. Today, I am going to discuss about unconventional machining process. In unconventional machining process, today I will discuss about one of the important machining process that is also known as water jet machining process. Dear student, I have already written all the points and diagrams so that it takes less time for covering the whole topics. Okay, now in this water jet machining, I will cover what is the working principle of the water jet machining, what are the different components are connected in water jet machining systems, and I will also try to describe about the what is the advantage, disadvantage and application of the WJM. Okay, now let us start. Water jet machining is also known as WJM. Okay, now WJM is a mechanical energy based non-traditional machining process used to cut and machine soft and non-metallic material. So water jet machining is basically used for the soft material, and it is work on the basis of mechanical energy system. Second points, it involves the use of high velocity of water jet is which used to cut soft workpiece. And in third point, it is similar to abrasive jet machining, which is also known as AJM. Abrasive jet machining is also a type of unconventional machining process. Now next point is, during this process kinetic energy is converted into pressure energy, and this induced a stress on the workpiece. Induced stress is so high enough that unwanted particles of the workpiece is automatically removed from the workpiece. Now it is the basically a small introduction about the water jet machining. I will describe many more. Now first understand from the schematic diagram of water jet machining. From the schematic diagram we can understand that there are many parts are assembled in the WJM. From the initial to final we can see that the first part is reservoir, then pump, next intensifier, accumulator, control valve, flow regulator and nozzle, finally to the workpiece. Now we have to understand the each and every parts working. So what is the working of reservoir? Reservoir is acts as a to collect, to store the water. And next is the pump. Here the pump is used generally hydraulic pump, and we know the working of the pump to lift the water, and now the pump will act here to lift the water of the reservoir to the intensifier. Now what is the intensifier? Intensifier is a pressure increasing device. Of what pressure? It will increase the pressure of the water, and the pressure level of which the intensifier will increase, it will be variable, and it may be from 200 to 400 MPa megapascal. Now from the intensifier the pressurized water will be flow to the accumulator. Now this is a pipe connection I have shown from the arrow. You can understand that it shows the flow of water in this manner. Now the pressurized water from the intensifier will flow to the accumulator. Accumulator will work as a temporary storage device which will store the pressurized water. Now from the accumulator the water will flow to the control valve. Control valve actually controls the direction of the water flow, and from the control valve the water finally enter into the flow regulator, where the flow regulator regulates the quantity of water to quantity of pressurized water to flow in the nozzle. Now from the nozzle you can see that the shape of nozzle is like this. The purpose of nozzle is like this to increase the velocity of the pressurized water, so that it can strike at the workpiece and removes the particles due to the erosion action. erosion action is generally is a mechanical action which is performed during the WJM. And now it is the your workpiece, and this one is a water jet. Now from the this schematic diagram, you can easily see that there is a small gap between the end of the nozzle and surface of the workpiece, and this gap is known as SOD, which is known as stand off distance. Now because we are studying about the unconventional machining process, so the facility of unconventional machining process is that the tool never touches the workpiece. Only a medium is used to remove the material from the workpiece. Now here the medium is the water. So stand off distance is the variable, and it is its distance is depends on the many factor. For example, what is the material, which type of shape we have to cut in the workpiece, what is the pressure of the water. So there are many factors on which stand off distance is depends in water jet machining. Now this is the if you understand this flow diagram, I have also written it in a text form. You can easily see from here. I have mentioned the heading working of WJM. Whatever we have studied in the earlier schematic diagram, all the things is written here. For example, I have described about the reservoir, and I have described about the pump. Hydraulic pump is used, as I have already mentioned. Intensifier will increase the pressure of the water up to level of 200 to 400 megapascal. Now pressurized water is then enter into the accumulator. Accumulator stores the water, and it will work as a temporary device. Now from the accumulator, the water will enter to the control valve, and it will provide the direction to the water. Now from the control valve, it will flow to the flow regulator. Finally it will come to the nozzle. So all the things which I have written here is I have already explained in the schematic diagram. So if you have understand the concept of schematic diagram, concept of the every component, so it will be very easy for you. There is no need to learn many more times about the working of WJM. Now the next slide is advantage of WJM. Now so I will try to finish it very fast. WJM relatively is a fast process. Okay. Second point is it prevents the formation of heat affected zone. What is the heat affected zone? As we have already studied in the during the welding process, there is a heat affected zone because there is a high temperature, we melt the material, but because we are using here as a working fluid is a water, so there is a no contact of the workpiece and tool, so obviously there is a no heat affected zone. Third point, excellent precision means tolerance of the order of plus minus 0.05 rate can be achieved by the WJM process. And fourth point is it does not produce any hazardous gases. Obviously, as we have mentioned that we are using here as a working fluid as a water, so there is no any hazardous gases, so it is also known as eco-friendly process. Now if any system have advantage, so there is a disadvantage too. So in disadvantage we can understand that first topic is only soft material can be achieved. So from the WJM process, only soft material can be machined, as I have already mentioned in the during the definition of the WJM. Second point is thick material cannot be easily machined. So it is usually used for the thin material. Thick material is difficult to machine by this process. Third point is initial investment is very high. Why initial investment is very high? As I have already shown in this schematic diagram, there is a accumulator, intensifier, flow rate, nozzle, control valve, storage device. So if you calculate the initial investment, then its cost is very high. Now what is the application of WJM? WJM is used to cut the thin non-metallic sheets. Second point, it is used for the cutting of machining of rubber, wood, ceramics, etc. And third point is it is mainly used for the machining of circuit boards. Okay friends, I think you all have understand the what is the working of WJM. It is very important to all of you. If you have any problem, please write down in the text. Thank you very much.